Hello and welcome to the 3D printing room at SDU for MMMI. Today we're going to teach you how to use these 3D printers and how to make 3D printing files using Bamboo Studio. The first thing you need to do when you want to start 3D printing is of course downloading the 3D printing software that you need to make 3D printing files. In our case that would be Bamboo Studio. Once the program has finished installing, you should be prompted to associate some files with Bamboo Studio. I recommend that you don't associate step files, but associate the other ones, as step files are usable to have associated with your CAD software of choice. Then you can simply run Bamboo Studio. When you open Bamboo Studio for the first time, you should be prompted with a setup wizard where you choose what region you're working from and skip joining a program for customer experience. Then when you're prompted to select a printer, you clear all and simply select the Bamboo Lab P1S, which is the printer we'll be using, and selecting next. When being prompted to select filament, simply uncheck every single one of them except generic PLA, as that's what we're working with at SDU, like this. And you do not need to install the Bamboo Network plugin, as the printers at SDU do not have network capabilities. Now you should be at the home screen for Bamboo Studio. From here we can begin 3D printing. Bamboo Studio accepts a wide range of 3D file types. As you saw earlier, it can take both STEP, STL, OBJ and 3MF file types. And to begin a new project, you either select Open Project and find a 3MF file type that you want to open, or you can create a new project and simply find the file that you wish to import and drag into the scene, and it should just appear. Now you should be at the prepare screen. This is where you're going to do the final preparations before you start your 3D print. In the center here, you can see the plate of your selected 3D printer with the object that you wish to 3D print on it. You can move the object to any point on the plate except for this corner down here that's reserved for the printing head. When you import files, they might be rotated at an odd angle, or you might even have multiple objects in one file. Bamboo Studio has some automatic tools for arranging and rotating the objects on the scene so that they're placed optimally for 3D printing. Our example will only need to 3D print one object. To the left of the plate, you'll see a menu with a bunch of options. It's separated into 3 sections. The top section is the printer. This should just be left at the Bamboo P1S. These settings shouldn't be changed, as these are what's set up for in the printers at SDU. The second one is for the project filament. Here you can change which set of filaments you want to use if you want to use the AMS system, but we're not going to go into that in this tutorial. Lastly, you're going to have the settings for the print process. This can be toggled to either advanced or just standard, and depending on what you have it toggled to, you have either 4 or 5 settings tabs with different settings. These can be left as default when you print normally, but one that we might want to talk about is support. Some projects, like this Benchy, might have sections that are either bridges or overhangs. Bridges are 2 pieces that are connected, like here, where there's a part of it that is supposed to be printed in thin air. And overhangs are similar, but only one of the edges are connected to something that's touching ground. As you might expect, it's pretty hard for the 3D printer to print in thin air, except in cases where the distance for bridges or overhangs is quite small. In these cases, you would need to support these points to make sure that the print doesn't fail. In general, Benchy should be able to print without supports because these areas are quite small, but for the purpose of this tutorial, we are going to enable supports so that we can show you how they work. In Bamboo Lab, these settings can be found under support, and then simply checking the option enable support. There are 2 types of support. There's either tree support or normal support, and that just defines the structure of the support when it is generated. Tree support grows sort of like a tree, which can be seen here in this illustration. and normal support looks a lot more just like square pillars that support the areas that need it, which can be seen in this illustration. In general, tree is the best option because it uses less material and is just as good at supporting the areas that need support. In fact, it might even be better at detecting the areas that need support. As you can see here, normal support can be a bit overkill. In some cases, the slicer might not add support at the correct positions, and you might want to add some support to a model yourself. Bamboo Studio normally automatically generates support, which can be seen by the auto next to the type of support. But if you select manual instead, you can select the model and then you can paint the areas that you think need support. This is useful if, for example, you might want to only support certain archways or a tip of a specific structure because it might fail during print. As you can see in this example, after I've painted it, the support is only generated at the points where I've painted. For this example, we will just use automatic tree support. Once you are happy with the settings that you have for your model, you are ready to slice the plate. This means that Bambu Labs generates a sliced version, meaning it just sorts it into layers and generates code for how the printer is supposed to print each layer. Once the plate is sliced, you can change the color scheme to line type to get a better view of how your model is being printed. Blue areas indicate overhangs or bottoms of prints. Oranges are wall prints, and the red are top or roofs, with green indicating support structures. On the right, you can scroll down to view each individual layer of the print, or scroll up to view layers from the bottom. And at the bottom, you can go through the iterations of the layer to see each operation that the slicer is making for that printed layer. Once you're happy with the print, you can select Export Place Slice File on this menu at the right, and then simply click the option, and you should be prompted to save the file somewhere on your computer. It should be a G-code file. G-code is simply the sort of code that the printer can interpret. It's basically a set of instructions that tells the printhead where to go and how to extrude filaments. I'm gonna save this right here as this file, just overwrite it, and we should be ready to print. Before you start printing, there are some things you need to make sure of. The first thing is you need to make sure that there's an available 3D printer. If you can find a 3D printer without any printing, that would be ideal. However, if you can find a 3D printer with a print that has been finished, that's also useful. If you find a 3D printer with print in it, feel free to remove the print from the printer, as long as you're careful when removing it as not to destroy it, and that you leave the print somewhere where it's visible and easy to find for the person who printed it. It is also a good idea to make sure that there is enough filament in the printer before you start printing. You can do that simply by looking at the filament roll on top of the printer, seeing roughly how much filament is left. When you're ready to print, the first thing you need to do is to remove the small SD card from the top of the printer. This is where you will store your 3D printing file. There is a dongle in the 3D printing room that accepts these small SD cards. You can simply insert them on the slot on the side and then insert the dongle into your computer. It has both a USB-C, USB-A and micro USB port. Once you've inserted the dongle into your computer, it is good practice to remove all previous 3D printing files from the SD card so that it doesn't fill up. And then you can simply move the file you've created to the SD card, and you're good to go. Remember to safely eject the dongle from your computer. Now you can simply reinsert the SD card in the printer. Make sure you do it the right side forward, and then you can select your 3D print, and if you've deleted the files from the SD card, it should be the only one available. Simply select it and press print. Now the printer should automatically start calibrating, and you simply need to wait. It's good practice to wait the first 5-10 minutes, simply to see that the print adheres properly to the printing surface and doesn't fail early. as that is the most common time for a 3D print to fail. Once the print is done, you can safely remove it from the 3D printer simply by taking it out. The plate is removable, and remember to remove all plastic from the plate, even the tiny strip that the 3D printer prints to purge the nozzle. If you're printing with support, now's the time to carefully remove the support from the 3D print, and you should be done. Congratulations, you've now completed your first 3D print. Remember to throw out excess filament. If you run into catastrophic problems like the printer stops working or if anything starts smoking, you can always contact Cal. He has an office right across the hall. He's the one responsible for the printers in this room. Now you know how to 3D print. There are a bunch of other settings you can change in the slicer. We haven't covered infill, we haven't covered speed and layer height, but for most of your prints, these settings should simply just be left at default. Good luck and start printing.